Picture this. Somewhere in the depths of theoretical physics, researchers have discovered that if time travel were ever possible, the universe has built-in safeguards so elegant and mysterious that they would automatically erase your memory of the journey. You could travel back in time, meet your younger self, even attempt to change history, but by the time you return to your starting point, you would remember none of it. The past would remain untouched, not because you failed to change it, but because the very fabric of reality would systematically undo every trace of your interference, including the memories in your own mind. Welcome back to another quiet journey through the mysteries of science and consciousness. I'm here with you as we explore one of the most fascinating discoveries in modern physics, a finding that challenges everything we thought we knew about time, memory, and the nature of reality itself. Tonight, we're diving into the world of quantum time loops, where the laws of physics become poetry and paradoxes resolve themselves through mechanisms so subtle they seem almost alive. It's a place where the universe appears to have its own immune system against contradiction, where entropy flows backward, and where the very concept of cause and effect begins to bend like light around a massive star. As always, you don't need to remember every detail or take notes. Just let these ideas wash over you like gentle waves on a shore. Sometimes the most profound insights come not from grasping tightly to facts, but from allowing concepts to settle naturally into the quiet spaces of your mind. Before we begin our exploration, take a moment to settle in. Notice your breathing, the weight of your body, the soft boundary between you and the space around you. In a few minutes, we're going to journey into realms where those boundaries become far more fluid than you might expect. To understand how time might loop back on itself, we need to start with Einstein's revolutionary insight about the nature of spacetime. In 1915, Einstein showed us that space and time aren't separate entities, but rather a unified fabric that can be stretched, compressed, and even twisted by the presence of mass and energy. Imagine space-time as a vast, flexible membrane. When you place a heavy ball in the center, it creates a depression. Roll a marble nearby, and it will spiral around the depression, following the curves created by the heavy object. This is essentially how gravity works, not as a force pulling objects together, but as curved space-time guiding their motion. But Einstein's equations revealed something even more extraordinary. Under certain extreme conditions, this fabric of space-time could potentially curve back on itself so dramatically that it forms what physicists call closed timelike curves. These aren't just mathematical curiosities, they're genuine solutions to Einstein's field equations, theoretical pathways through space-time that loop back to their own beginning. Think of it this way: if space-time is like a river, most of the time it flows steadily forward, carrying us from past to future. But in certain exotic circumstances, the river might form an eddy, a circular current that brings water back to where it started. A closed time-like curve is like that eddy, but instead of water, it's the flow of time itself that circles back. These curves could theoretically exist around rapidly rotating massive objects, or perhaps through the exotic geometry of traversable wormholes. The mathematics is clear, even if the physical reality remains deeply uncertain. Einstein's universe, it turns out, is far stranger than even he initially imagined. Once physicists realized that Einstein's equations allowed for time loops, they immediately confronted a problem that seemed to shatter the very foundations of logical thought: the grandfather paradox. The scenario is deceptively simple. Imagine you travel back in time and accidentally prevent your own grandparents from meeting. If they never meet, your parents are never born. If your parents are never born, you're never born. But if you're never born, you can't travel back in time to prevent your grandparents from meeting. It's a perfect logical contradiction. For decades, this paradox seemed to prove that time travel was impossible, regardless of what Einstein's equations might allow. Logic itself appeared to serve as a cosmic prohibition against temporal loops. The universe, it seemed, couldn't tolerate such contradictions. But then quantum mechanics entered the picture, and everything changed. As you listen to this, take a moment to consider how many apparent contradictions exist in your own life. Perhaps you've experienced moments when two seemingly opposite truths felt equally valid, when paradox became not a problem to solve, but a mystery to inhabit. In 1991, physicist David Deutsch proposed something radical. What if the grandfather paradox wasn't a contradiction at all, but simply a misunderstanding of how quantum systems behave in the presence of time loops? Deutsch's insight was elegant in its simplicity. In the quantum world, particles don't exist in single, definite states until they're measured. Instead, they exist in superpositions, simultaneously occupying multiple possible states at once. A quantum particle can be spinning clockwise and counterclockwise, here and there, alive and dead, all at the same time. Deutsch realized that this quantum superposition could resolve the grandfather paradox completely. Instead of creating a logical contradiction, a time traveler would simply exist in a quantum superposition of states. They would simultaneously exist in a reality where they killed their grandfather and a reality where they didn't. Both outcomes would be equally real, equally valid, woven together in the strange mathematics of quantum mechanics. Imagine standing at a crossroads where instead of choosing one path, you walk down all paths simultaneously. From your perspective, you're making one journey, but from the universe's perspective, you're exploring every possible outcome at once. The contradiction disappears because there is no single timeline to contradict. This wasn't just theoretical speculation. Deutsch showed mathematically that quantum systems interacting with closed timelike curves would naturally evolve into self-consistent states. The universe, it seemed, had its own mechanism for avoiding paradoxes. Around the same time, another physicist named Seth Lloyd was developing a different approach to the same problem. Lloyd's solution was even more dramatic than Deutsch's superposition model. Lloyd proposed that the universe uses a mechanism called post-selection to prevent paradoxes. In this model, any quantum state that would lead to a logical contradiction is simply forbidden from existing. It's as if the universe has a built-in filter that automatically eliminates paradoxical possibilities before they can manifest. Think of it like this. Imagine you're shuffling a deck of cards, but the deck is quantum mechanical. Most of the time, any arrangement is possible. But if you're shuffling near a closed timelike curve, the deck would automatically exclude any arrangements that would create a temporal paradox. The universe itself would post-select only those configurations that maintain logical consistency. In Lloyd's model, the grandfather paradox doesn't occur because the universe simply won't allow it, not through coincidence or intervention, but through the fundamental structure of quantum mechanics itself. The gun would misfire, you would change your mind, or some other factor would intervene to preserve causality. This approach is both more restrictive and more mysterious than Deutsch's superposition solution. Rather than allowing paradoxical states to exist in quantum limbo, Lloyd's universe actively prevents them from occurring in the first place. You might think these ideas would remain forever in the realm of pure theory, impossible to test in any real laboratory. But in 2014, researchers found a way to simulate these quantum time travel scenarios using carefully entangled photons. The experiments were elegant in their design. Scientists created pairs of entangled photons, particles of light that remain connected even when separated by vast distances. They programmed one photon to travel what amounted to a few billionths of a second backward in time, with a mission to terminate its earlier state, essentially creating a microscopic version of the grandfather paradox. The results were striking. The closer the photon got to successfully terminating its past state, the more frequently the experiment failed. It was as if the universe had a built-in mechanism that prevented the photon from creating a temporal paradox. The quantum system itself seemed to resist any configuration that would violate causality. These experiments provided the first empirical evidence that quantum mechanics might indeed prevent time travel paradoxes automatically. The universe, it appeared, had mechanisms for self-protection that operated at the most fundamental level of reality. Take a breath here and notice how this might relate to your own experience. Have you ever felt that life has a way of preventing certain outcomes, as if there are invisible guardrails guiding events toward consistency and meaning? This feeling, whether real or imagined, echoes something profound about how reality seems to maintain its own coherence. Recently, physicist Dr. Gavesino made a discovery that revolutionized our understanding of quantum time loops. Using rigorous mathematical models, he explored what would actually happen to a system, including any conscious observers, traveling along a closed, timelike curve. His findings were both beautiful and unsettling. According to his calculations, any system traveling through a time loop would undergo what he called spontaneous quantum restructuring. This isn't just a technical phrase, it describes something profound about the nature of time, memory, and identity itself. Dr. Gavesino discovered that entropy, the measure of disorder in a system, behaves in extraordinary ways along closed, time-like curves. In normal circumstances, entropy always increases, giving time its forward arrow. This is why coffee cools down, why broken eggs don't spontaneously reassemble, and why memories form but don't naturally disappear. But on a closed time-like curve, entropy must return to its starting value by the end of the loop. This creates what Dr. Gavesino calls an entropic U-turn. Entropy increases for the first half of the journey, reaches a maximum, and then decreases back to its original level. This reversal has profound implications for memory and consciousness. Since memory formation is fundamentally tied to increases in entropy, the reversal of entropy during the second half of the journey would systematically erase all memories formed during the loop. A time traveller would return to their starting point with no recollection of their temporal adventure. What emerges from all this research is something almost poetic in its elegance. The universe appears to have multiple redundant mechanisms for preventing temporal paradoxes. Whether through quantum superposition, post-selection, or entropy reversal, reality seems determined to maintain its own logical consistency. This suggests something profound about the nature of existence itself. We live in a cosmos that appears to value coherence and self-consistency above all else. The laws of physics don't just describe how things behave, they seem to embody a kind of cosmic wisdom that prevents contradiction and maintains the integrity of cause and effect. Consider for a moment how this might reflect patterns in your own life. How often do apparent contradictions resolve themselves naturally? How frequently do situations that seem impossible somehow find their own solutions? Perhaps the same principles that govern quantum time loops operate in subtler ways throughout our daily experience. The research suggests that even if time travel were possible, even if closed time-like curves exist somewhere in our universe, the past would remain forever unchangeable. Not because we lack the power to alter it, but because the fundamental structure of reality automatically prevents such alterations. To understand why these quantum protections work so elegantly, we need to explore one of the most beautiful theorems in mathematics, the Poincaré recurrence theorem. This theorem states that any finite isolated system will eventually return arbitrarily close to its initial state. It's a mathematical guarantee that patterns repeat, that cycles complete themselves, that what begins must somehow return to its beginning. In the context of everyday life, Poincaré recurrence operates on timescales so vast they're essentially meaningless. The theorem guarantees that if you open a bottle of perfume in a sealed room, the molecules will eventually, through random motion, find their way back into the bottle. But this would take longer than the age of the universe, making it practically impossible to observe. However, on a closed time-like curve, Poincaré recurrence happens on a predetermined schedule. The loop forces the system to return to its starting state within a specific time frame, making the mathematical guarantee into a physical reality. This connection between pure mathematics and the physics of time travel reveals something profound about the nature of reality. Mathematical truths don't just describe the universe, they seem to be woven into its very fabric. The elegant theorems discovered by human minds operating on abstract principles turn out to govern the most exotic phenomena in cosmic physics. As we continue our exploration, pause for a moment to appreciate this mysterious connection between mathematics and reality. The equations that exist in the realm of pure thought somehow capture the deepest truths about the physical world. It's as if the universe is written in the language of mathematics, waiting for conscious minds to learn how to read its subtle poetry. In our next segment, we'll explore what this means for consciousness itself, and how the principles governing time loops might illuminate the very nature of memory, identity, and the continuity of experience. We'll discover that the quantum mechanisms protecting causality might be operating in ways that touch the deepest questions about what it means to be a conscious observer in a quantum universe. The journey into time's deepest mysteries has only just begun, and the most profound revelations still lie ahead. In the quiet mathematics of Dr. Gavesino's equations, something remarkable emerges that goes beyond memory, erasure, and entropy reversal. When a system travels along a closed, time-like curve, the energy levels within that system don't just change randomly. Instead, they undergo what physicists call spontaneous discretization, a process so precise it seems almost orchestrated by the universe itself. Think of energy like the notes on a piano. In ordinary circumstances, quantum systems can occupy various energy states, like fingers finding different keys across the keyboard. But along a closed time-like curve, something extraordinary happens. The system's energy levels automatically lock into specific, finely tuned values, as if an invisible hand is selecting only certain notes that will create a perfect harmony. This discretization isn't random or chaotic. It's governed by Wigner's theorem, a fundamental principle in quantum mechanics that ensures mathematical consistency across temporal loops. The energy levels organize themselves with surgical precision, spacing themselves at exactly the right intervals to guarantee that the system returns to its precise original state by the end of the loop. imagine a cosmic tuning fork that resonates through time itself. Just as a tuning fork produces only specific frequencies, a system traveling through a time loop can only exist in energy states that maintain perfect consistency across the temporal circuit. Any other configuration would create the kind of logical contradiction that the universe seems determined to prevent. This spontaneous organization reveals something profound about the nature of reality. The cosmos doesn't just tolerate consistency, it actively enforces it through mechanisms that operate at the deepest level of physical law. Energy itself becomes a guardian of causality, arranging itself in patterns that preserve the logical structure of existence. As you contemplate this idea, notice how it might echo patterns in your own life. Have you ever experienced moments when circumstances seem to arrange themselves with uncanny precision, when events aligned in ways that felt almost too perfect to be coincidental? While we can't claim that life operates like a quantum time loop, there's something resonant about the idea that reality has its own tendency toward harmony and consistency. One of the most haunting questions raised by quantum time loop research concerns the nature of observation itself. If a conscious observer travels through a closed, timelike curve, what happens to their subjective experience? Do they maintain awareness during the journey, only to have it erased at the end? Or does consciousness itself follow different rules in the presence of temporal paradoxes? Dr. Gavasino's research suggests something both fascinating and unsettling. Any observer traveling along a closed, timelike curve would experience what he calls entropic amnesia. As entropy reverses during the second half of the journey, all the neural processes that create memory would systematically unwind. Thoughts would unthink themselves, experiences would dissolve back into potential, and consciousness would retrace its own steps backward through time. This raises profound questions about the continuity of identity. If you travelled through a time loop and returned with no memory of the journey, would you still be the same person? Or would the version of you that completed the loop be fundamentally different from the one who began it, separated by an experience that exists in the mathematical structure of reality, but not in the realm of conscious memory? Some interpretations suggest that consciousness might operate differently than other physical processes in time loops. Perhaps awareness exists in a realm that transcends the ordinary flow of entropy, maintaining some form of continuity even when memory fails. But this remains deeply speculative, touching on questions that bridge physics and philosophy in ways we're only beginning to understand. Consider for a moment your own relationship with memory and identity. How much of who you are depends on your ability to remember your experiences? If those memories were somehow erased or altered, would the essential you remain unchanged? These questions, while abstract, touch on something fundamental about the nature of consciousness and its relationship to the physical world. While Dr. Gavasino's work focuses on single timeline consistency, another interpretation of quantum time travel leads to an entirely different conclusion. The many worlds interpretation, developed by physicist Hugh Everett III, suggests that quantum systems don't just exist in superposition until measured. Instead, all possible outcomes of quantum events actually occur, each in its own separate branch of reality. When applied to time travel, this interpretation creates a staggeringly complex picture. Instead of returning to your original timeline, a time traveler would create new branches of reality with every action they took in the past. The grandfather paradox disappears not through quantum consistency mechanisms, but through the multiplication of worlds. In this model, if you travelled back in time and prevented your grandparents from meeting, you wouldn't erase yourself from existence. Instead, you would create a new branch of reality where you were never born, while the original branch continues unchanged. You would exist simultaneously in a world where you were born and a world where you weren't. With both realities being equally valid and equally real, this interpretation transforms the lonely journey of time travel into something more like cosmic gardening. Each decision, each action in the past would bloom into entire universes of possibility. The time traveler becomes not just an observer of history, but a creator of infinite worlds, a sculptor working with the clay of causality itself. The mathematical elegance of many worlds theory is matched only by its philosophical implications. If every possible outcome occurs somewhere in the multiverse, then free will takes on new meaning. Every choice you make creates worlds where you chose differently. Every path you didn't take exists in some parallel reality where another version of you is walking it. Pause here and imagine the vastness of this possibility. If many worlds theory is correct, then in some universe, every decision you've ever made played out differently. There are versions of you who chose different careers, different relationships, different paths entirely. While this remains unproven and highly speculative, it offers a compelling framework for thinking about choice, possibility, and the nature of existence itself. Recent developments in quantum computing have opened unexpected windows into the mechanics of time loops. Researchers at the University of Oxford have discovered that quantum computers can serve as experimental platforms for studying closed timelike curves, transforming abstract theoretical concepts into concrete computational experiments. In these quantum circuit simulations, researchers create systems where quantum information appears to travel backward in time, interacting with its own past states. The circuits model scenarios where a quantum bit or qubit encounters information from its own future, creating computational versions of temporal paradoxes. The results are striking. Quantum computers with access to these simulated time loops can solve certain problems that would be impossible for conventional quantum systems. They can perform what researchers call perfect state discrimination, distinguishing between quantum states that would normally be impossible to tell apart. It's as if having access to temporal loops grants computational abilities that transcend the normal limits of information processing. This connection between time travel and computation reveals something profound about the nature of information itself. In quantum mechanics, information isn't just data stored in systems. It's a fundamental aspect of reality that can flow backward through time, interact with itself, and create new possibilities for processing and understanding. Think about how this might relate to your own experience of time and information. Have you ever had moments of intuitive knowing, when information seemed to arrive from nowhere, when solutions to problems appeared before you fully understood the questions? While we can't claim these experiences involve actual time travel, they hint at the mysterious ways information moves through consciousness and reality. At the deepest level, the prevention of time travel paradoxes may be rooted in one of the most fundamental laws of physics, the second law of thermodynamics. This law states that entropy, or disorder, always increases in isolated systems. It's why hot coffee cools down, why perfume spreads through a room, and why broken things don't spontaneously reassemble themselves. The second law gives time its arrow, creating the forward flow from past to future that shapes our entire experience of reality. But in a closed time-like curve, this law faces an unprecedented challenge. If a system must return to its starting point, Entropy cannot simply increase forever. It must somehow find its way back to its original value. Dr. Gavasino's research reveals how this challenge resolves itself through what he calls thermodynamic symmetry. The entropy of a system travelling through a time loop increases during the first half of the journey, reaches a maximum at the temporal midpoint, then decreases back to its starting value during the second half. The result is a perfectly symmetric curve, like a mountain with identical slopes on both sides. This entropy reversal creates a cascade of effects throughout the system. Chemical reactions reverse themselves, biological processes unwind, and most remarkably, the neural processes that create memory dissolve back into their original states. The time traveller returns to their starting point not just in space and time, but in every measurable aspect of their physical and mental state. This mechanism reveals something beautiful about the relationship between time and consciousness. Memory isn't just stored information, it's a thermodynamic process, a pattern of increased entropy that gives our experiences their forward direction. When entropy reverses, so too does the formation of memory, ensuring that the past remains forever unchanged in the mind of any traveller who attempts to alter it. As you reflect on this, consider how memory shapes your own relationship with time. Each moment of experience creates permanent changes in your brain, increasing entropy in ways that make the moment irreversible. Your consciousness is, in a very real sense, a thermodynamic process, a river of increasing entropy that carries you from past to future. Underlying all these mechanisms, from quantum superposition to entropy reversal, operates what physicists call the self-consistency principle. This principle states that only those histories of the universe that are logically consistent can actually occur. It's as if reality has its own immune system, automatically rejecting any possibility that would create a logical contradiction. The principle doesn't require external intervention or conscious oversight. Instead, it emerges naturally from the mathematical structure of physics itself. The equations that govern quantum mechanics and general relativity contain within them a kind of logical DNA that ensures consistency across all possible timelines. In practical terms, this means that any attempt to create a temporal paradox would be thwarted not by coincidence or intervention, but by the fundamental laws of nature. This principle suggests something profound about the nature of reality. We live in a cosmos that values logical coherence above all else. The laws of physics aren't just descriptive rules, they're expressions of a deeper cosmic wisdom that maintains the integrity of existence itself. If you enjoy drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready. Consider how this principle might manifest in your own life. How often do situations that seem impossible somehow resolve themselves? How frequently do potential contradictions find their own solutions? While we can't claim that daily life operates according to the self-consistency principle, there's something resonant about the idea that reality has its own tendency toward harmony and resolution. The theoretical beauty of quantum time loop research becomes even more compelling when we examine the experimental evidence. In 2014, researchers at the University of Queensland conducted groundbreaking experiments using entangled photons to simulate the grandfather paradox at the quantum level. The experimental setup was elegant in its simplicity. Scientists created pairs of entangled photons, particles of light that remain mysteriously connected even when separated by vast distances. They programmed one photon to travel backward in time by a few billionths of a second with a mission to terminate its earlier state, creating a microscopic version of the grandfather paradox. The results provided striking evidence for the universe's built-in paradox prevention mechanisms. As the photon approached success in its self-destructive mission, the experiment began to fail with increasing frequency. It was as if the quantum system itself was resisting any configuration that would violate causality. These experiments represent something remarkable in the history of science. For the first time, researchers were able to test theories about time travel paradoxes in actual laboratory conditions. The photons weren't travelling through time in the classical sense, but they were experiencing quantum mechanical equivalents of temporal loops, complete with all the associated paradoxes and resolutions. The consistency of the results across multiple trials suggests that the universe's resistance to paradoxes isn't a rare or fragile phenomenon. It appears to be a robust feature of quantum mechanics, operating reliably at the most fundamental level of reality. Take a moment to appreciate the profound implications of this research. We now have experimental evidence that the universe contains mechanisms for preventing logical contradictions. Reality isn't just mathematically consistent, it actively maintains its own consistency through processes we're only beginning to understand. One of the most intriguing aspects of quantum time loop research concerns the fate of information itself. In quantum mechanics, information is considered fundamental, more basic than matter or energy. The quantum state of any system contains all possible information about that system, encoded in the mathematical structure of its wave function. But what happens to information when it encounters a closed timelike curve? Does it follow the same rules as matter and energy, or does information operate according to different principles when confronted with temporal paradoxes? Recent research suggests that information in time loops behaves in ways that challenge our most basic assumptions about knowledge and memory. While the physical state of a system must return to its starting configuration, the information contained within that state follows a more complex path through the loop. Some theoretical models propose that information can exist in quantum superposition across multiple temporal states simultaneously. In this view, a time traveler would carry information from multiple possible timelines, even though they retain conscious memory of none of them. The information exists in the quantum substrate of their being, invisible to consciousness, but potentially detectable through subtle quantum measurements. This leads to fascinating questions about the nature of knowledge itself. If information can survive processes that erase conscious memory, then there might be forms of knowing that transcend ordinary awareness. The time traveler might return with no conscious memory of their journey, yet their quantum state might contain encoded information about experiences they can't remember having. Consider how this might relate to your own relationship with knowledge and intuition. Have you ever found yourself knowing things you couldn't explain, having insights that seem to arrive from beyond the reach of conscious reasoning? While we can't claim these experiences involve actual quantum information from time loops, they point to the mysterious ways knowledge moves through consciousness and reality. To truly understand quantum time loops, we need to explore the geometric nature of time itself. In Einstein's universe, time isn't a universal river flowing at the same rate everywhere. Instead, it's part of the fabric of space-time, capable of being stretched, compressed, and even twisted into complex shapes. Closed time-like curves represent one of the most exotic possibilities in this geometric landscape. They occur when space-time curves back on itself so dramatically that the future connects to the past, creating a temporal loop that exists as a real feature of cosmic architecture. The mathematics of these curves reveals something beautiful about the relationship between geometry and causality. Just as a circle has no beginning or end, a closed timelike curve has no temporal start or finish. Past and future become relative concepts, meaningful only in relation to a traveller's position along the curve. This geometric perspective transforms our understanding of causality itself. Instead of cause and effect operating in a linear sequence, they become features of spacetime topology. Events don't just happen in time, they exist as permanent features of the universe's geometric structure, connected by curves that may loop back on themselves in ways we can barely imagine. The visualization of these concepts challenges our ordinary spatial thinking. We're accustomed to 3 dimensions of space and 1 of time, but closed time-like curves exist in the 4-dimensional spacetime that encompasses both. They're curves that we can describe mathematically, but can never fully visualize, existing in dimensions our minds weren't evolved to perceive directly. As you contemplate these ideas, notice how they stretch your imagination beyond its usual boundaries. The universe revealed by modern physics is far stranger and more wonderful than everyday experience suggests. We live embedded in a cosmic geometry that includes possibilities we can barely conceive, let alone directly experience. Perhaps the most profound questions raised by quantum time loop research concern the nature of consciousness itself. If memory can be erased and entropy reversed, what happens to the subjective experience of awareness during a journey through time? Some researchers speculate that consciousness might follow different rules than other physical processes when confronted with closed time-like curves. While memory formation depends on irreversible thermodynamic processes, consciousness itself might exist in a realm that transcends ordinary entropy flow. This possibility raises fascinating questions about the relationship between mind and time. If consciousness can somehow persist through entropy reversal, then awareness might be more fundamental than the physical processes that usually support it. The time traveller might experience the loop even if they can't remember it, carrying forward some ineffable trace of the journey that exists beyond the reach of memory. Other interpretations suggest that consciousness dissolves and reforms along with everything else during the entropy reversal process. In this view, the observer who completes the loop isn't quite the same person who began it, even though they possess identical memories and physical states. They're more like a perfect copy, indistinguishable from the original, except for the invisible discontinuity created by the temporal journey. These questions touch on some of the deepest mysteries in philosophy and neuroscience. What makes you continuously you across time? Is consciousness a process or a thing? Can identity survive gaps in continuity? Or does it require unbroken connection from moment to moment? While we may never fully answer these questions, they illuminate something important about our ordinary experience of time and consciousness. Every moment of awareness carries forward something from the previous moment, creating the sense of continuous self that persists throughout our lives. The mechanisms that might govern consciousness in time loops help us understand the processes that create continuity in ordinary time as well. Take a breath here and notice your own stream of consciousness. Each thought arises from previous thoughts. Each moment of awareness builds on what came before. This continuity, which we usually take for granted, represents one of the most remarkable features of conscious existence. Whether or not time travel is possible, the mere contemplation of its effects on consciousness reveals the miracle of ordinary awareness. The exploration of quantum time loops opens windows into questions that extend far beyond physics into the deepest mysteries of existence itself. As we continue our journey through these ideas, we'll discover how the principles governing temporal paradoxes might illuminate not just the nature of time, but the fundamental structure of reality and consciousness. As we've journeyed through the mathematical landscapes of time loops and paradox prevention, we encounter something even more mysterious: the principle of emergence. In quantum systems traveling through closed time-like curves, new properties can spontaneously arise that weren't present in the original configuration. These emergent features exist nowhere in the initial conditions, yet they manifest as natural consequences of the temporal journey itself. Think of emergence like a jazz improvisation. The musicians begin with a simple melody, but as they play together, harmonies and rhythms emerge that none of them planned or anticipated. The music becomes something greater than the sum of its parts, revealing possibilities that existed only in potential until the performance brought them into being. In quantum time loops, this emergence takes on an almost mystical quality. Systems can return to their starting point, carrying information patterns that weren't there originally, not memories which are erased by entropy reversal, but deeper structural changes in the quantum substrate itself. It's as if the journey through time leaves invisible scars on reality, traces that exist below the threshold of conscious detection, but above the level of pure randomness. Dr. Gavasino's equations suggest that these emergent properties follow their own conservation laws. Just as energy and momentum are conserved in ordinary physics, the information patterns created by temporal loops appear to be preserved according to principles we're only beginning to understand. The universe doesn't just prevent paradoxes, it actively creates new forms of order through the very process of temporal consistency. Consider how emergence might operate in your own life. How often do complex situations resolve themselves in ways that no one could have predicted? How frequently do new possibilities arise from the intersection of apparently unrelated events? While we can't claim these experiences involve quantum time loops, they hint at the same principle of emergence that governs temporal paradoxes. Among all the paradoxes associated with time travel, perhaps none is more haunting than the Bootstrap paradox, also known as a causal loop. This occurs when information or objects exist without any discernible origin, trapped in endless cycles of cause and effect. Imagine this scenario: a time traveller goes back and gives Shakespeare a book containing all of Shakespeare's plays. Shakespeare publishes the plays, becoming the great playwright we know from history. Centuries later, someone finds the published works and takes them back in time to give to Shakespeare. But who actually wrote the plays? The information exists in a perfect loop, with no identifiable point of creation. In the context of quantum mechanics, Bootstrap paradoxes take on even stranger properties. Information that emerges from closed time-like curves might exist in what physicists call superposition of origins. The data simultaneously came from the future and the past, from external sources and internal generation, existing in a quantum state that defies our ordinary understanding of causation. Recent theoretical work suggests that Bootstrap paradoxes might be more common than we imagine, operating at the quantum level throughout ordinary spacetime. Every quantum measurement might involve tiny loops of information that bootstrap themselves into existence, creating the apparent randomness we observe in quantum events. This perspective transforms our understanding of creativity and innovation. Perhaps new ideas don't arise from nowhere, but emerge from subtle information loops that connect present insight with future possibility. The moment of inspiration might be less like discovering something new and more like completing a temporal circuit that was always meant to be closed. As you reflect on your own creative experiences, notice the mysterious quality of inspiration. Ideas seem to arrive from beyond the reach of conscious reasoning, carrying with them a sense of completeness that suggests they existed somewhere before you found them. This feeling, whether literal or metaphorical, echoes the strange logic of Bootstrap paradoxes. One of the most profound questions raised by quantum time loop research concerns the role of consciousness in maintaining temporal consistency. If quantum mechanics requires observers to collapse wave functions, what happens when those observers travel through closed timelike curves? Some interpretations suggest that consciousness operates according to different temporal rules than other physical processes. While matter and energy must return to their original states, awareness might exist in a realm that transcends ordinary causality. The conscious observer might be the one element in the system that maintains continuity across the temporal loop. This possibility raises fascinating questions about the relationship between mind and time. If consciousness can somehow persist through entropy reversal and memory erasure, then awareness might be more fundamental than the physical processes that usually support it. The observer might experience the loop in ways that leave no trace in memory, but create subtle changes in the structure of consciousness itself. Other models propose that consciousness fractures during temporal journeys, splitting into multiple streams that follow different paths through the loop. The observer who completes the journey might be a quantum superposition of all possible conscious states, carrying forward traces of experiences from timelines that never quite occurred. These ideas remain deeply speculative, existing at the intersection of physics and philosophy, where mathematics meets mystery. Yet they point towards something important about the nature of awareness and its relationship to the flow of time. Consciousness might not just observe temporal paradoxes, it might be the key to resolving them. Take a moment to notice your own stream of awareness as you listen to these ideas. Each thought arises and dissolves in the flow of consciousness, creating patterns that persist across moments but never remain exactly the same. This dynamic quality of awareness, its ability to maintain continuity while constantly changing, might hold clues to how consciousness could navigate the strange territory of temporal loops. Recent developments in theoretical physics suggest that all the information contained in a volume of space can be represented on its boundary, like a hologram that stores three-dimensional images in two-dimensional surfaces. This holographic principle has profound implications for understanding quantum time loops and the nature of reality itself. If the universe is truly holographic, then the information patterns created by closed time-like curves might be encoded on the boundaries of spacetime itself. The paradox prevention mechanisms we've explored, from quantum superposition to entropy reversal, might be manifestations of information processing occurring at the most fundamental level of reality. In this view, spacetime isn't just a stage on which events unfold, it's an active information processing system that maintains consistency across all possible timelines. The universe computes its own consistency, running continuous calculations to ensure that logical contradictions cannot arise. This perspective transforms our understanding of physical law. Instead of seeing the laws of physics as external rules imposed on matter and energy, we can think of them as emergent properties of cosmic information processing. The universe doesn't just follow laws, it continuously creates and enforces them through processes we're only beginning to comprehend. The holographic principle also suggests that the boundary between observer and observed might be more fluid than we imagine. If reality is fundamentally informational, then consciousness might be one of the universe's ways of processing and organizing information about itself. The observer doesn't just witness reality, they participate in its ongoing creation. Consider how this might relate to your own experience of reality. Every moment of perception involves processing vast amounts of information, selecting certain patterns to notice while ignoring others. Your consciousness doesn't just passively receive reality, it actively constructs your experience from the infinite possibilities available in each moment. Quantum entanglement, Einstein's spooky action at a distance, takes on new dimensions when applied to closed timelike curves. Recent theoretical work suggests that particles can become entangled not just across space, but across time itself, creating connections between past and future states that transcend ordinary causality. In temporal entanglement, a particle in the present might share quantum correlations with its own past or future states. Measuring the particle now would instantaneously affect its properties at other points in its temporal journey, even if those points are separated by the entropy reversal that occurs in time loops. This form of entanglement might explain how the universe maintains consistency across temporal paradoxes. If past and future states are quantum mechanically connected, then any attempt to create a contradiction would automatically trigger compensating changes throughout the temporal loop. The system would heal itself through quantum correlations that operate outside ordinary time. The implications extend beyond time travel into our understanding of causality itself. If temporal entanglement is real, then the sharp distinction between cause and effect might be an illusion created by our limited perspective. Past, present, and future might be more interconnected than we ever imagined, woven together by quantum threads that transcend the ordinary flow of time. This interconnectedness might manifest in subtle ways throughout ordinary experience. Have you ever felt connected to your past or future selves in ways that seem to transcend memory and expectation? While we can't claim these experiences involve actual temporal entanglement, they point toward a deeper unity that might underlie the apparent separation between different moments in time. Throughout our exploration, we've encountered the fundamental asymmetry that gives time its direction, the arrow of time created by increasing entropy. But in closed time-like curves, this arrow doesn't just point forward, it curves back on itself, creating temporal geometries that challenge our most basic assumptions about the nature of time. Dr. Gavassino's research reveals that the arrow of time in temporal loops follows what he calls symmetric causality. During the first half of the journey, entropy increases and time flows forward in the familiar direction. But at the midpoint of the loop, something remarkable happens. The arrow begins to reverse and causality starts flowing backward toward the starting point. This creates a temporal landscape unlike anything in ordinary experience. Imagine standing at the peak of a mountain where you can see both the path you climbed and the path you'll descend, but they're the same path viewed from different directions. The temporal loop creates a similar perspective on causality, allowing events to flow both forward and backward while maintaining perfect consistency. The reversal of time's arrow has profound implications for consciousness and memory. During the forward phase of the journey, experiences accumulate, and memories form in the normal way. But during the backward phase, these processes reverse themselves, unwinding the mental traces of the journey until the traveller returns to their original state of awareness. This symmetric structure suggests that time itself might be more flexible than we imagine. The forward flow of time that shapes our daily experience might be just one possible configuration of temporal order, stable and consistent, but not necessarily universal or eternal. As you contemplate these ideas, notice your own relationship with time's passage. The steady flow from past to future feels so natural that it's hard to imagine any alternative. Yet the mathematical possibility of temporal loops reminds us that even the most basic features of reality might be more contingent and mysterious than everyday experience suggests. Underlying all the mechanisms we've explored, from quantum superposition to entropy reversal, operates what cosmologists call the consistency conjecture. This principle states that the universe possesses an inherent tendency toward logical self-consistency that operates at every level of reality, from quantum mechanics to cosmic structure. The consistency conjecture isn't just a rule imposed on the universe from outside, it's an emergent property of the mathematical structures that govern physical law. Reality doesn't just happen to be consistent, it actively maintains its own consistency through processes that operate automatically and continuously. In the context of time loops, this self-correction manifests through multiple redundant mechanisms. If quantum superposition fails to prevent a paradox, entropy reversal provides a backup system. If memory erasure doesn't fully resolve contradictions, spontaneous discretization fine-tunes the system until consistency is restored. The universe has multiple layers of protection against logical breakdown. This redundancy suggests something profound about the nature of existence. We live in a cosmos that values coherence and consistency above all else, a universe that would rather erase memories, reverse entropy, or split into multiple realities than tolerate logical contradictions. The consistency conjecture might extend beyond physics into other domains of experience. Consider how often situations that seem impossible somehow find their own solutions. How frequently apparent contradictions resolve themselves through processes we don't fully understand. While we can't claim that daily life operates according to cosmic consistency principles, there's something resonant about the idea that reality has its own wisdom for maintaining harmony and order. When we step back and examine all the quantum mechanisms that prevent temporal paradoxes, a remarkable pattern emerges. The universe appears to possess something like an immune system designed to protect causality from logical infection. Just as biological immune systems recognize and eliminate foreign threats, reality seems to have evolved mechanisms that automatically identify and neutralize temporal contradictions. This temporal immune system operates through multiple complementary processes. Quantum superposition allows contradictory states to coexist without creating logical problems. Post-selection eliminates paradoxical configurations before they can manifest. Entropy reversal erases the memory traces that would make contradictions psychologically real. Spontaneous discretization fine-tunes energy levels to maintain perfect consistency. The elegance of this system suggests that consistency isn't an accident or afterthought, but a fundamental design principle of reality itself. The universe doesn't just tolerate logical coherence, it actively enforces it through mechanisms that operate at the deepest level of physical law. This perspective transforms our understanding of the relationship between mind and cosmos. We're not separate observers looking at an alien universe. We're part of a reality that shares our commitment to logical consistency. The same principles that govern our reasoning processes operate throughout the fabric of spacetime itself. As you reflect on this idea, consider how it might relate to your own experience of consistency and contradiction in daily life. When faced with logical problems, your mind naturally seeks resolution, harmony, and coherence. Perhaps this tendency reflects something deeper than individual psychology, something that connects human consciousness to the fundamental structure of reality itself. If you enjoy drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready. The scientific exploration of quantum time loops inevitably leads us into philosophical territory, raising questions about the nature of existence, identity, and meaning in a universe where temporal paradoxes are possible but automatically prevented. If closed timelike curves exist, what does it mean to have a history? If memories can be erased by entropy reversal, what gives life continuity and meaning? If multiple timelines can exist in quantum superposition, which version of events is real? These questions don't have easy answers, but they illuminate something important about the relationship between time and meaning. One interpretation suggests that meaning doesn't depend on remembering experiences, but on having them. Even if a time traveler returns with no memory of their journey, the experiences themselves remain real in the mathematical structure of space-time. The universe remembers even when consciousness forgets. Another perspective proposes that meaning emerges from the very mechanisms that prevent paradoxes. The elaborate quantum processes that maintain temporal consistency might be expressions of a deeper cosmic purpose, a universe-wide commitment to logical coherence that gives existence its fundamental structure and direction. These philosophical implications extend beyond time travel into everyday life. Every moment of consciousness involves navigating apparent contradictions, resolving conflicting desires, and maintaining personal consistency across time. The mechanisms that govern quantum time loops might be microscopic versions of the processes that create meaning and coherence in ordinary experience. Consider your own relationship with time and meaning. How much of your sense of purpose depends on memory and continuity? How much derives from the immediate experience of being present in each moment? The contemplation of temporal loops, even if they remain forever theoretical, can illuminate the mysterious ways that consciousness creates meaning from the flow of time. As quantum computing technology advances, researchers are developing increasingly sophisticated methods for testing the principles that govern temporal paradoxes. While we may never create actual time machines, we can simulate their essential features using quantum circuits that manipulate information in ways that mirror the behavior of closed time-like curves. These quantum simulations are revealing unexpected connections between time travel and computation. Systems with access to temporal loops can solve certain problems that would be impossible for conventional quantum computers, suggesting that the mathematical structures governing time and information are more deeply connected than previously imagined. Future experiments might explore whether consciousness itself follows different rules when simulated temporal loops are involved. If awareness operates according to principles distinct from other physical processes, quantum computers might provide the first laboratory tools for studying consciousness directly. The implications extend beyond pure research into practical applications. understanding the mechanisms that maintain consistency in temporal loops might lead to new approaches for error correction in quantum computers, more robust methods for processing information, and novel insights into the relationship between computation and physical law. As you contemplate these possibilities, notice how the exploration of impossible scenarios can illuminate practical realities. Even if time travel remains forever beyond our reach, the attempt to understand its implications reveals new truths about the nature of reality, consciousness, and the fundamental structure of existence itself. While our exploration has focused on individual travelers and small systems, the principles governing quantum time loops might operate on cosmic scales as well. Some cosmological models suggest that the universe itself might contain closed timelike curves, regions where the flow of time forms vast loops that encompass galaxies and eons. If such cosmic time loops exist, they would be subject to the same consistency principles we've explored, but operating on scales that dwarf human imagination. Entire civilizations might rise and fall within temporal circuits, their histories automatically adjusted by quantum mechanisms to prevent paradoxes on a galactic scale. This possibility transforms our understanding of cosmic evolution and the arrow of time on the largest scales. The universe might not just be expanding and cooling, it might be maintaining its own temporal consistency through processes that operate across billions of years and countless star systems. The search for evidence of cosmic time loops has become an active area of research in cosmology. Scientists are looking for subtle patterns in the cosmic microwave background radiation that might reveal the signatures of temporal consistency mechanisms operating on the scale of the observable universe itself. These investigations remind us that the principles we've explored, while exotic and strange, might be fundamental features of reality at every scale. From quantum particles to cosmic structures, the universe might be engaged in a continuous process of maintaining its own logical consistency through mechanisms we're only beginning to understand. As our exploration draws toward its close, it's worth reflecting on how the contemplation of quantum time loops might change our relationship with time in ordinary life. Even if we never encounter actual temporal paradoxes, the knowledge that they're theoretically possible but automatically prevented reveals something profound about the nature of reality and our place within it. The mechanisms that govern time loops, from quantum superposition to entropy reversal, operate continuously throughout ordinary spacetime. Every quantum measurement might involve tiny loops of causality. Every moment of consciousness might participate in the universe's ongoing effort to maintain consistency across time. This perspective invites a different relationship with the passage of time. Instead of seeing time as a river carrying us inexorably toward an uncertain future, we might envision ourselves as participants in a vast cosmic process of temporal self-organization, contributing through our choices and awareness to the universe's ongoing creation of consistent reality. The knowledge that paradoxes are automatically prevented might also offer a different perspective on regret and possibility. If the universe truly maintains its own consistency, then the past remains perfect as it is. Not because it couldn't have been different, but because it achieved the only configuration that maintains logical coherence with everything that followed. This doesn't eliminate the importance of choice or the reality of alternative possibilities. Instead, it suggests that our choices participate in a larger process of temporal organization that transcends individual decision-making while still honoring the reality of free will and personal responsibility. As you move forward through time from this moment, carry with you the awareness that you're part of something extraordinary. A universe that values consistency enough to develop elaborate mechanisms for maintaining it. A cosmos that would rather erase memories than tolerate contradictions. A reality that actively protects its own logical integrity through processes operating at every scale from quantum to cosmic. The quantum paradoxes that make time loop back on itself reveal not just the strange possibilities hidden in the mathematics of physics, but the profound commitment to coherence that underlies all existence. We live within a reality that is simultaneously more mysterious and more trustworthy than everyday experience suggests. A universe that maintains its own wisdom through mechanisms we're only beginning to glimpse. Whether closed time-like curves exist somewhere in the depths of space, whether time travel will ever become possible, whether the multiverse branches into infinite possibilities, the exploration of these questions illuminates something essential about the nature of reality and consciousness. We exist within a cosmos that protects its own consistency through quantum mechanisms so elegant they seem almost alive, ensuring that the past remains unchangeable, not through rigid determinism, but through the universe's own commitment to logical harmony. The next time you experience the forward flow of time, the accumulation of memories, the sense of moving from past toward future, remember that you're participating in one of the most remarkable processes in the cosmos, the ongoing creation of consistent reality through the mysterious dance of quantum mechanics and consciousness, entropy and information, possibility and actuality. Time may loop back on itself in the exotic mathematics of closed time-like curves, but it carries us forward through the gentle certainty that the universe knows how to maintain its own deepest truths. And in that certainty, we find not just a resolution of paradoxes, but a profound sense of trust in the mysterious wisdom that underlies all existence. Next time, we'll explore how this same quantum consistency might shape not just time itself, but the very nature of perception and reality in the science of reality and illusion. Why no two minds see the same world? Until then, rest well in the knowledge that you exist within a cosmos committed to its own coherence, a universe that loops time back on itself only to discover that some truths transcend even the strangest possibilities of physics. As we drift deeper into the implications of temporal paradoxes, we encounter something that challenges our most fundamental assumptions about the relationship between mind and reality. The quantum mechanisms that prevent time travel paradoxes, superposition, post-selection, entropy, reversal, operate through principles that bear a striking resemblance to the processes of consciousness itself. Consider how your mind handles contradictions. When faced with conflicting information or paradoxical situations, consciousness doesn't simply break down or freeze in logical paralysis. Instead, it employs sophisticated mechanisms for maintaining coherence, selective attention that filters out contradictory details, memory consolidation that smooths over inconsistencies, and narrative construction that weaves disparate elements into meaningful wholes. These mental processes mirror, in remarkably precise ways, the quantum mechanisms that maintain temporal consistency. Just as the universe uses superposition to allow contradictory states to coexist without creating logical problems, consciousness uses cognitive flexibility to hold multiple perspectives simultaneously without experiencing psychological breakdown. The parallel extends to memory and time perception. Your brain doesn't store memories like a computer stores files, preserving exact replicas of past experiences. Instead, each act of remembering reconstructs the past, subtly altering it to maintain consistency with your current understanding and emotional state. This ongoing revision of personal history serves a function remarkably similar to the entropy reversal that erases memories in temporal loops. Some interpretations suggest, though this remains deeply speculative, that consciousness and quantum mechanics might share more than just analogous structures. Perhaps awareness operates according to principles that transcend classical physics, participating in the same fundamental processes that govern quantum superposition and temporal consistency. Take a moment here to notice your own stream of consciousness. As you listen, thoughts arise and dissolve, memories surface and fade, attention shifts and focuses. The continuity you experience across these changes involves processes that maintain psychological consistency while allowing for constant transformation, not unlike the mechanisms that would govern consciousness in a temporal loop. This connection between mind and quantum mechanics doesn't suggest that consciousness creates reality or that thoughts directly influence quantum events. Rather, it points toward the possibility that awareness and quantum mechanics might be expressions of the same underlying principles of consistency, coherence, and self-organization that operate throughout nature. One of the most intriguing aspects of Dr. Gavesino's research concerns what happens to information that exists below the threshold of conscious memory. While entropy reversal would erase all accessible memories of a temporal journey, the mathematical structure of the quantum state would retain traces of the experience, encoded in ways that transcend ordinary awareness. This phenomenon has parallels throughout neuroscience and psychology. Your brain continuously processes vast amounts of information that never reaches conscious awareness. Yet this unconscious processing influences behavior, decision-making, and even emotional responses in subtle but measurable ways. You might find yourself drawn to certain places, people, or choices without understanding why, guided by information patterns that exist below the level of explicit memory. In the context of temporal loops, this suggests that a time traveler might return carrying information from their journey in forms that consciousness cannot access directly. The quantum substrate of their being would contain encoded patterns from experiences they cannot remember having, creating a kind of temporal intuition that operates beyond the reach of ordinary awareness. Recent research in quantum biology, though still in its early stages, suggests that living systems might naturally operate according to quantum principles in ways we're only beginning to understand. Some studies indicate that certain biological processes, from photosynthesis to possibly even neural computation, might employ quantum coherence to achieve efficiencies that classical physics cannot explain. If consciousness truly operates through quantum processes, as some speculative theories propose, then the information persistence we see in temporal loops might reflect something fundamental about how awareness maintains continuity across time. Each moment of consciousness might involve quantum computations that preserve information patterns while allowing surface experiences to change and flow. This doesn't mean that consciousness is supernatural or that the mind operates outside physical law. Rather, it suggests that the physical processes underlying awareness might be more subtle and quantum mechanical than classical neuroscience has assumed. The same principles that govern information persistence in time loops might operate continuously in ordinary consciousness, creating the sense of continuity and identity that persists across moments. As you reflect on your own sense of persistent identity, notice how much of who you are seems to transcend specific memories or experiences. There's something about your essential nature that feels continuous across time, even though every cell in your body replaces itself regularly and your memories constantly change. This persistent core might reflect the same information preservation principles that would operate in quantum temporal loops. The research into quantum time loops reveals something remarkable about the nature of correlation and connection across time. If temporal entanglement is real, as some theoretical models suggest, then events separated by years or decades might be connected by quantum threads that transcend ordinary causality. This possibility offers a new perspective on experiences that seem to involve meaningful coincidences or synchronicities. While there's no scientific consensus that such experiences involve actual quantum entanglement, the mathematical structures governing temporal correlation might provide a framework for understanding how meaning and connection emerge from apparently random events. Consider moments in your own life when circumstances seemed to align with uncanny precision, when the right person appeared at exactly the right moment, or when information you needed arrived through seemingly impossible chains of coincidence. Traditional physics would describe these as random events that happen to create meaningful patterns, but the principles governing quantum time loops suggest other possibilities. If information can indeed flow through temporal correlations, then the boundary between past, present, and future might be more permeable than everyday experience suggests. The decision you make today might be correlated with events from your past or future in ways that create patterns of meaning and connection across time. This remains deeply speculative, far beyond what current science can confirm or deny. But the mathematical possibility of temporal entanglement invites us to consider whether the universe might be more interconnected across time than classical physics allows. Perhaps the meaningful coincidences that punctuate human experience reflect genuine correlations operating through dimensions we can barely perceive. The key insight from quantum time loop research is that correlation doesn't require direct causal connection. Events can be linked through the underlying structure of spacetime itself, creating patterns that appear meaningful even when no classical cause and effect relationship exists. As you move through your daily life, pay attention to the subtle connections and correlations that seem to emerge spontaneously. While we cannot claim these involve quantum entanglement, they might reflect the same principles of connection and coherence that would govern consciousness in temporal loops. The universe appears to be far more interconnected than surface appearances suggest. Throughout our exploration of quantum time loops, we've encountered the central mystery of quantum mechanics, the role of observation in determining reality. In standard quantum theory, the act of measurement appears to collapse quantum superpositions into definite states, transforming probability clouds into concrete outcomes. When applied to temporal loops, this observer effect takes on new dimensions of complexity and mystery. If consciousness plays a role in collapsing quantum wave functions, what happens when that same consciousness travels through closed timelike curves? Does awareness maintain its reality-shaping properties, or do temporal loops create new rules for the relationship between mind and matter? Some interpretations suggest that consciousness might serve as a stabilizing factor in temporal paradoxes, providing continuity across the quantum mechanisms that prevent logical contradictions. The observer might be the one element in the system that maintains coherence across entropy reversal, memory erasure, and quantum superposition. This possibility transforms our understanding of the relationship between awareness and physical reality. Instead of consciousness being simply a passive observer of quantum events, it might be an active participant in the universe's ongoing effort to maintain logical consistency. Every moment of awareness might contribute to the cosmic process of reality creation and temporal organization. Other models propose that consciousness itself undergoes quantum evolution during temporal journeys, existing in superposition states that mirror the quantum mechanical processes governing the rest of the system. The observer doesn't just witness paradox resolution, they participate in it through the quantum nature of awareness itself. These ideas remain highly speculative, existing at the frontier where physics meets philosophy and neuroscience, but they point towards something important about the nature of consciousness and its relationship to the fundamental structure of reality. Take a breath here and notice the quality of your own awareness as you engage with these ideas. Each moment of conscious attention involves selecting certain aspects of reality to focus on while allowing others to fade into the background. This selective aspect of consciousness might reflect the same principles that govern quantum measurement and reality creation throughout the universe. The observer effect in quantum mechanics reminds us that the boundary between mind and matter, between consciousness and cosmos, might be more fluid than everyday experience suggests. Whether or not consciousness directly influences quantum events, the mere act of awareness appears to be intimately connected to the processes that create definite reality from quantum possibility. While quantum time loops remain theoretical constructs, the principles they reveal about consistency, coherence, and the resolution of paradoxes might offer insights into healing and psychological transformation. The mechanisms that prevent temporal contradictions, from quantum superposition to entropy reversal, parallel many of the processes that support mental health and emotional well-being. Consider how trauma therapy often involves revisiting past experiences, not to change them, but to alter their relationship to present consciousness. The traumatic memory doesn't disappear, but its emotional charge can be transformed through processes that mirror the quantum resolution of temporal paradoxes. Just as the universe uses multiple redundant mechanisms to maintain temporal consistency, psychological healing often involves multiple approaches working together. Cognitive restructuring that creates new narrative frameworks, somatic practices that release trapped energy patterns, and mindfulness techniques that create space between consciousness and conditioned responses. The entropy reversal that erases memories in time loops has therapeutic parallels as well. While we cannot literally erase traumatic memories, certain practices appear to reduce their emotional intensity by interrupting the neural patterns that maintain psychological distress. The past remains factually unchanged, but its impact on present consciousness can be fundamentally transformed. This doesn't suggest that quantum mechanics directly causes healing, or that consciousness operates according to the same rules as temporal loops. Rather, it points toward the possibility that the principles governing consistency and paradox resolution might be universal features of complex systems, whether quantum mechanical, psychological, or biological. Some therapeutic approaches explicitly work with concepts of time and temporal relationship. Past life regression, family constellation work, and certain forms of shamanic healing operate on the premise that healing can occur through altered relationships with time and causality. While these practices remain controversial and lack scientific validation, they reflect intuitive understanding of principles that quantum physics is only beginning to formalize. As you consider your own relationship with past experiences, notice how memories can feel more or less emotionally charged, depending on your present state of consciousness. The same event can feel traumatic or transformative, depending on the context of awareness in which it's held. This flexibility in temporal relationship might reflect something fundamental about how consciousness navigates the landscape of time and memory. The Bootstrap paradoxes we explored earlier, where information exists without clear origin, might offer new perspectives on creativity and inspiration. Many artists, writers, and innovators describe the creative process as receiving ideas from sources beyond their conscious understanding. The work seems to arrive already complete, as if it existed somewhere before they discovered it. This experience of receiving rather than creating might reflect genuine features of how information moves through time and consciousness. If temporal correlations truly exist, then inspiration might involve accessing information patterns that exist in quantum superposition across multiple temporal states. The mathematical possibility of closed timelike curves suggests that information might flow through dimensions we cannot directly perceive, creating loops of cause and effect that transcend linear time. A creative work might be simultaneously influenced by its own future reception and impact, creating feedback loops that exist outside ordinary temporal sequence. While this remains highly speculative, it offers a framework for understanding experiences that seem to transcend normal causality. The moment of inspiration might be less like generating something new and more like completing a temporal circuit that connects present consciousness with patterns of possibility that exist across time. This perspective doesn't diminish the role of conscious effort, practice, and skill in creative work. Instead, it suggests that creativity might involve participating in larger processes of information organization that operate throughout the universe. The individual creator becomes a focal point where cosmic patterns of possibility crystallize into specific expressions. Many contemplative traditions recognize similar principles in their understanding of inspiration and insight. The idea that wisdom comes through emptying oneself to receive, rather than trying to generate, reflects this intuitive recognition of how information might flow through consciousness from sources beyond individual understanding. As you reflect on your own creative experiences, notice the mysterious quality of genuine inspiration. Ideas often seem to arrive with a sense of completeness and rightness that suggests they existed somewhere before conscious awareness discovered them. This feeling, whether literal or metaphorical, echoes the strange logic of Bootstrap paradoxes and temporal information loops. The principles governing quantum time loops might extend beyond individual consciousness into the broader patterns of ecological and biological organization. Living systems display remarkable abilities to maintain coherence and consistency across time, employing mechanisms that bear striking similarities to the paradox prevention systems we've explored. Consider how ecosystems maintain stability while constantly changing. Individual organisms are born and die, species evolve and adapt, yet the overall pattern of ecological relationship persists across centuries and millennia. This dynamic stability might reflect the same principles of consistency maintenance that operate in quantum temporal loops. At the cellular level, biological systems employ sophisticated mechanisms for maintaining genetic consistency across generations while allowing for evolutionary adaptation. DNA repair mechanisms automatically correct errors that could lead to logical inconsistencies in genetic information, much like the quantum mechanisms that prevent temporal paradoxes. The immune system provides another biological parallel to cosmic consistency mechanisms. Just as the universe appears to have developed methods for recognizing and eliminating logical contradictions, immune systems identify and neutralize threats to biological coherence through processes that operate automatically and continuously. These biological examples don't prove that living systems employ quantum temporal loops, but they suggest that the principles of consistency maintenance might be universal features of complex organization. From quantum mechanics to ecology to psychology, systems seem to develop mechanisms for maintaining coherence while allowing for transformation and growth. Some speculative theories in biology propose that evolution itself might employ quantum mechanical principles, exploring multiple possible futures simultaneously before settling into specific adaptations. While this remains unproven, it reflects the same logic that governs quantum superposition in temporal paradoxes. As you consider your own place within the larger web of ecological relationship, notice how your individual existence participates in patterns that transcend personal biography. The oxygen you breathe, the water you drink, the elements that compose your body have all been part of countless other living systems across deep time. You exist within cycles and connections that operate across scales from molecular to cosmic. While our exploration has focused primarily on individual systems and consciousness, the principles governing quantum time loops might operate on cosmological scales as well. Some theoretical models suggest that the universe itself might contain closed timelike curves, regions where the flow of time forms vast loops that encompass galaxies and eons. If such cosmic time loops exist, they would be subject to the same consistency principles we've explored, but operating on scales that dwarf human imagination. The evolution of entire galactic clusters might be guided by quantum mechanical processes that maintain temporal coherence across billions of years. This possibility transforms our understanding of cosmic evolution and the arrow of time on the largest scales. The universe might not just be expanding and cooling according to thermodynamic principles, it might be engaged in a continuous process of maintaining its own temporal consistency through mechanisms that operate across vast scales of space and time. The cosmic microwave background radiation, the afterglow of the Big Bang, might contain subtle signatures of these consistency mechanisms. Scientists are developing increasingly sophisticated methods for detecting patterns that could reveal whether the universe employs temporal loop structures to maintain logical coherence on cosmological scales. Some models of cosmic inflation suggest that our observable universe might be just one bubble in a vast foam of temporal loops, each maintaining its own consistency while remaining causally isolated from the others. In this view, the consistency mechanisms we've explored might be fundamental features of reality at every scale, from quantum to cosmic. The search for evidence of cosmic time loops represents one of the most ambitious projects in modern cosmology. If successful, it would reveal that the same principles governing individual consciousness and quantum mechanics operate throughout the entire structure of space-time itself. As you contemplate the possibility that you exist within a cosmos that might be maintaining its own temporal consistency through processes operating across unimaginable scales, take a moment to appreciate the profound interconnection between the smallest and largest features of reality. The quantum mechanisms that would govern your consciousness in a time loop might be expressions of the same principles that shape the evolution of the universe itself. Recent developments in neuroscience and theoretical physics have converged on a remarkable possibility. Consciousness might be a form of information integration that operates according to principles similar to those governing quantum temporal loops. This integrated information theory suggests that awareness emerges from the complex patterns of information processing that occur throughout the brain and possibly throughout the universe itself. If consciousness truly operates as a form of cosmic computation, then the consistency mechanisms we've explored in temporal loops might be expressions of the same information processing principles that create awareness. The universe might be engaged in a continuous process of integrating information across space and time, with consciousness serving as local manifestations of this cosmic computational process. This perspective suggests that the observer effect in quantum mechanics might not be a special property of consciousness, but rather a natural consequence of information integration processes that operate throughout reality. Every quantum measurement might involve information processing that resembles in essential features the processes that create conscious awareness. The implications extend beyond individual consciousness to questions about the nature of reality itself. If the universe truly operates as an information processing system, then physical law might emerge from computational processes rather than existing as external rules imposed on matter and energy. Some theoretical models propose that spacetime itself might be an emergent property of cosmic information processing, with the consistency mechanisms that prevent temporal paradoxes representing fundamental computational protocols that maintain the integrity of reality's information structure. While these ideas remain highly speculative, they suggest fascinating connections between consciousness, quantum mechanics, and the fundamental nature of existence. The same principles that would govern awareness in temporal loops might be operating continuously throughout ordinary spacetime, creating the information patterns that we experience as physical reality. As you notice your own stream of consciousness, consider the possibility that awareness might be participating in information processing patterns that extend far beyond individual psychology. Each thought, each moment of attention, might contribute to cosmic computation processes that maintain the consistency and coherence of reality itself. As our exploration of quantum time loops draws toward its natural conclusion, it's worth considering how these ideas might influence our approach to living in ordinary time. Even if we never encounter actual temporal paradoxes, the knowledge that they're theoretically possible but automatically prevented reveals something profound about the nature of reality and our place within it. The consistency mechanisms that govern time loops operate continuously throughout ordinary space-time, though in ways too subtle for direct observation. Every quantum measurement might involve tiny loops of causality. Every moment of consciousness might participate in the universe's ongoing effort to maintain logical coherence across time. This understanding might support a different relationship with regret, possibility, and the passage of time. If the universe truly maintains its own consistency through quantum mechanical processes, then the past remains perfect as it is, not because it couldn't have been different, but because it represents the only configuration that maintains coherence with the present moment. This doesn't eliminate the importance of choice or the reality of alternative possibilities. Rather, it suggests that our decisions participate in a larger process of temporal organization that transcends individual will while still honoring the reality of free will and personal responsibility. The knowledge that paradoxes are automatically prevented might also offer comfort in situations that seem impossible or contradictory. If reality truly possesses mechanisms for maintaining its own consistency, then even the most difficult circumstances might contain seeds of resolution that operate through processes we don't fully understand. Many contemplative traditions recognize similar principles in their understanding of acceptance and surrender. The practice of trusting in larger processes while still taking appropriate action reflects intuitive recognition of the same consistency principles that govern quantum temporal loops. As you move forward through time from this moment, consider carrying with you the awareness that you're part of something extraordinary, a universe that values coherence enough to develop elaborate mechanisms for maintaining it, a cosmos that would rather employ quantum superposition than tolerate logical contradictions. The principles governing time loops remind us that reality operates according to a logic more subtle and elegant than everyday experience suggests. We exist within a cosmos that actively protects its own consistency through mechanisms that span scales from quantum to cosmic, ensuring that the flow of time maintains its fundamental integrity even in the face of the most exotic theoretical possibilities. Throughout our journey through the landscape of quantum temporal loops, we've encountered recurring themes that weave together into a coherent understanding of time, consciousness, and reality. The mechanisms that prevent temporal paradoxes, quantum superposition, entropy reversal, spontaneous discretization, and post-selection all serve the same fundamental purpose: maintaining the logical consistency of existence itself. These mechanisms reveal something profound about the nature of reality. We live within a universe that prioritizes coherence and consistency above all else, a cosmos willing to employ the strangest features of quantum mechanics, rather than tolerate logical contradictions. This commitment to consistency operates automatically and continuously, creating the stable foundation that allows existence to unfold in orderly patterns. The connection between these cosmic consistency mechanisms and the processes of consciousness suggests something remarkable about the relationship between mind and universe. The same principles that would maintain temporal coherence in exotic time loops operate continuously in ordinary awareness, creating the sense of continuity and identity that persists across moments. This doesn't mean that consciousness creates reality or that thoughts directly influence quantum events. Rather, it suggests that awareness and quantum mechanics might be expressions of the same underlying principles of information integration and consistency maintenance that operate throughout nature. The mathematical elegance of these connections points toward a universe that is, simultaneously, more mysterious and more trustworthy than everyday experience suggests. Reality operates according to principles that ensure logical coherence while allowing for creativity, growth, and transformation. The cosmos maintains its own integrity through processes so subtle they seem almost alive. As we've seen, these principles extend from quantum mechanics through biology, psychology, and possibly even cosmic evolution. The same logic that prevents temporal paradoxes might govern ecological stability, immune system function, and the emergence of meaning from apparent chaos. This integration suggests that the contemplation of time loops, even if they remain forever theoretical, illuminates fundamental truths about existence itself. The universe reveals its deepest nature through its response to impossible scenarios, showing us the elegant mechanisms that maintain consistency in the face of potential contradiction. Our exploration began with the paradox of time looping back on itself, and as we near its conclusion, we discover that this circularity reflects something fundamental about the nature of understanding itself. Each new insight into quantum temporal loops reveals deeper layers of mystery, creating cycles of knowledge that seem to loop back on themselves in patterns of increasing sophistication. The Poincaré recurrence theorem that governs entropy reversal in time loops might apply to consciousness as well. Understanding, like physical systems, might follow cycles that eventually return to their starting points, but at higher levels of integration and complexity. Each journey through these ideas brings us back to wonder, but wonder enriched by the mathematical precision of quantum mechanics. This cyclical nature of understanding reflects patterns that appear throughout nature and consciousness. Seasons return, but never quite the same. Biological cycles repeat, but always with variation. Psychological development follows spiraling paths that revisit familiar themes from new perspectives. The contemplation of temporal loops reminds us that linear progress might be less fundamental than cyclical deepening. Knowledge doesn't just accumulate in straight lines. It develops through recursive processes that circle back on themselves, creating understanding that transcends the sum of its parts. In this sense, our journey through quantum time loops participates in the same recursive logic that governs the phenomena we've explored. The act of contemplating temporal consistency might itself be a form of temporal consistency, creating loops of meaning that connect present understanding with possibilities that exist across time. As you reflect on your own relationship with these ideas, notice how understanding seems to develop through cycles of confusion and clarity, questions and insights, wonder and comprehension. This process might reflect the same recursive principles that govern quantum loops and cosmic consistency. Perhaps the most profound teaching that emerges from our exploration of quantum temporal loops is the gentle nature of paradox resolution. The universe doesn't prevent logical contradictions through force or violence, but through elegant mechanisms that honour all possibilities while maintaining essential consistency. Quantum superposition allows contradictory states to coexist without creating conflict. Entropy reversal erases memories gently, returning consciousness to its original state without trauma or disruption. Post-selection eliminates paradoxical possibilities by simply making them unavailable, like paths that close themselves automatically when they would lead to contradiction. This gentle approach to paradox resolution might offer wisdom for navigating the apparent contradictions that arise in ordinary life. Instead of forcing resolution through struggle or denial, we might learn to hold contradictory truths in quantum superposition, allowing them to coexist until natural processes reveal appropriate paths forward. The patience required for entropy reversal in time loops might parallel the patience needed for healing psychological wounds or resolving interpersonal conflicts. Some contradictions resolve themselves not through immediate action, but through allowing time and natural processes to restore balance and consistency. The universe's commitment to consistency, revealed through quantum temporal loop research, suggests that reality itself tends toward resolution and harmony. This doesn't guarantee that individual situations will resolve quickly or easily, but it points toward deep principles of order that operate even in the face of apparent chaos and contradiction. As you encounter contradictions and paradoxes in your own life, consider the possibility that they might resolve themselves through processes more subtle and patient than immediate logical analysis. Sometimes the most profound solutions emerge not from forcing resolution, but from allowing natural consistency mechanisms to operate across time. In the deepest mathematics of quantum temporal loops, we discover structures of infinite recursive complexity. Each loop might contain smaller loops, which themselves contain even smaller loops, creating fractal patterns of temporal organization that extend across scales from Planck time to cosmic epochs. This recursive structure suggests that reality might be organized according to principles that transcend simple linear causation. Instead of events following each other in straightforward chains of cause and effect, existence might unfold through nested cycles of influence that create meaning and connection across vast scales of space and time. The contemplation of infinite recursion in temporal loops evokes the same sense of vertigo that arises from contemplating infinite space or eternal time. Yet this vertigo might be appropriate, reflecting the genuine depth and mystery of existence itself. We live within structures of organization so complex and recursive that they exceed the capacity of any finite mind to fully comprehend. This humility in the face of infinite recursion might be essential for authentic relationship with the cosmos. The universe reveals itself not as a problem to be solved or a system to be controlled, but as an inexhaustible mystery to be explored with wonder and respect. The recursive nature of temporal loops reflects similar patterns throughout consciousness and nature. Each level of biological organization, from molecular to cellular to organismic to ecological, displays recursive patterns that create coherence across scales. Your thoughts emerge from neural networks, which emerge from cellular processes, which emerge from molecular interactions, creating consciousness through levels of organization that loop back on themselves in ways we're only beginning to understand. The infinite recursion of temporal loops reminds us that every answer opens new questions. Every resolution reveals deeper mysteries. This isn't a failure of understanding, but a reflection of reality's inexhaustible depth. We exist within structures so complex that their full comprehension might require infinite time, making every moment of partial understanding precious and significant. As you contemplate these nested loops within loops, notice how your own consciousness exhibits similar recursive patterns. Each thought influences future thoughts, which circle back to modify their own origins. Memory reconstructs the past, which shapes present perception, which determines future memory formation. The mind creates loops within loops within loops, participating in the same recursive logic that governs quantum temporal paradoxes. When we step back and observe the full landscape of quantum temporal loops, what emerges is something remarkably musical in its structure. The mechanisms that prevent paradoxes operate like instruments in a vast orchestra, each contributing its voice to a symphony of consistency that plays across the dimensions of space and time. Quantum superposition provides the harmonic foundation, allowing multiple notes to sound simultaneously without creating discord. Entropy reversal creates the rhythmic structure, marking time through cycles of increase and decrease that give temporal loops their characteristic shape. Post-selection acts like a conductor, ensuring that only harmonious combinations manifest in the final performance. The mathematical equations that govern these processes possess an elegance that approaches poetry. They describe not just mechanical interactions between particles, but relationships of meaning and consistency that transcend simple physical causation. The universe appears to be engaged in a continuous process of composition, creating reality through principles of harmony rather than force. This musical metaphor isn't merely poetic, but reflects genuine mathematical relationships. Many physicists have noted connections between quantum mechanics and harmonic principles, suggesting that reality might be organized according to patterns that mirror the structures underlying music and mathematics. The symphony of consistency extends beyond individual, temporal loops into the broader structure of spacetime itself. Every quantum interaction contributes to the ongoing composition, adding notes to a piece that began with the Big Bang and continues evolving through every moment of cosmic history. As you listen to these ideas, notice the rhythm of your own breathing, the gentle cadence of thoughts arising and dissolving. Your consciousness participates in this cosmic symphony, adding its unique voice to patterns of consistency that extend from quantum scales to cosmic dimensions. You exist not as a separate observer, but as an instrument in the universal orchestra, contributing to the music of existence itself. Throughout our exploration, we've encountered the recurring theme of limits, not just the limits of what we can know about temporal loops, but the limits of knowledge itself. Quantum mechanics reveals a universe that maintains essential mysteries, even as it yields to mathematical precision. The more we understand about reality's deeper structures, the more we discover how much remains unknown. This edge where knowledge meets mystery isn't a boundary to be crossed, but a frontier to be explored with wonder and humility. The quantum mechanisms that prevent temporal paradoxes operate through principles we can describe mathematically, but never fully comprehend intuitively. They remind us that reality exceeds the capacity of any finite mind to grasp completely. Yet this limitation isn't a failure, but a feature of existence itself. The inexhaustibility of mystery ensures that consciousness always has new territories to explore, new questions to contemplate, new possibilities to discover. We live within a cosmos that offers endless depths for investigation while maintaining its essential unknowability. The research into quantum time loops exemplifies this balance between knowledge and mystery. We can calculate the precise mechanisms that would prevent temporal paradoxes, simulate their effects in laboratory conditions, and explore their implications for consciousness and reality. Yet the deeper questions they raise about the nature of time, identity, and existence remain as mysterious as ever. This perpetual mystery might be essential for maintaining the sense of wonder that drives both scientific investigation and contemplative exploration. If the universe revealed all its secrets at once, the joy of discovery would disappear. Instead, reality offers itself gradually, layer by layer, ensuring that every answer opens new questions and every understanding deepens the appreciation of what remains unknown. As you reflect on your own relationship with knowledge and mystery, notice how the most satisfying understanding often comes not from grasping answers completely, but from developing better questions. The contemplation of quantum time loops doesn't resolve the mystery of existence but deepens it, revealing new dimensions of wonder within the familiar experience of moving through time. While quantum time loops may remain forever beyond direct experience, the principles they reveal about consistency, coherence, and paradox resolution offer practical wisdom for navigating the complexities of ordinary life. The universe's commitment to maintaining logical consistency through gentle, elegant mechanisms provides a model for approaching personal contradictions and interpersonal conflicts. Consider how the principle of quantum superposition might apply to holding conflicting perspectives or emotions. Rather than forcing premature resolution, there might be wisdom in allowing contradictory truths to coexist until natural processes reveal appropriate paths forward. The anxiety of not knowing can transform into the spaciousness of holding multiple possibilities. The entropy reversal that occurs in temporal loops suggests something profound about the nature of healing and transformation. While we cannot literally reverse the entropy of traumatic experiences, consciousness possesses remarkable abilities to transform the relationship between past events and present awareness. The facts of history remain unchanged, but their emotional charge can diminish through processes that mirror the elegant mechanisms of quantum consistency. The post-selection principle that eliminates paradoxical possibilities before they can manifest might parallel the intuitive wisdom that guides us away from choices that would create unnecessary conflict or contradiction. Sometimes the best decision isn't the one we consciously calculate, but the one that emerges naturally when we trust in processes larger than individual reasoning. These applications remain metaphorical rather than literal. We cannot claim that daily life operates according to quantum mechanical principles, or that consciousness directly influences physical reality. But the contemplation of temporal loops illuminates patterns of consistency and resolution that appear throughout nature and human experience. The practical mysticism that emerges from this contemplation involves learning to trust in processes that transcend individual understanding, while still taking appropriate action within the sphere of personal responsibility. It's a balance between effort and surrender, between knowing and wondering, between grasping and allowing. The principles governing quantum time loops might extend beyond individual consciousness into the realm of collective human experience. Communities, cultures, and civilizations display patterns of consistency maintenance that bear striking similarities to the quantum mechanisms that prevent temporal paradoxes. Social systems develop elaborate mechanisms for maintaining cultural coherence across time, from legal structures that ensure consistency in decision-making to educational institutions that preserve knowledge across generations. These collective consistency mechanisms might reflect the same deep principles that govern quantum temporal loops. The way communities respond to potential contradictions and conflicts often mirrors the universe's approach to paradox prevention. Successful societies develop methods for allowing conflicting perspectives to coexist without destroying social fabric. Much like quantum superposition permits contradictory states to exist simultaneously. When social contradictions threaten community stability, cultures often employ processes that resemble entropy reversal, returning to foundational principles and values that restore coherence and direction. The collective memory of communities can be refreshed and renewed in ways that maintain essential continuity while allowing for growth and adaptation. This doesn't mean that human societies operate according to quantum mechanical laws, but rather that the principles of consistency, maintenance, might be universal features of complex systems, whether quantum, biological, psychological, or social. The same logic that prevents temporal paradoxes might guide the evolution of collective wisdom. The contemplation of quantum time loops from this collective perspective suggests that individual consciousness exists within larger patterns of consistency that extend across communities, cultures, and possibly even species. Your thoughts and choices participate in collective processes that maintain coherence across scales from personal to planetary. As you consider your own participation in human community, notice how your individual consistency contributes to larger patterns of social harmony and meaning. The same principles that would govern consciousness in temporal loops might be operating continuously in the collective human endeavour to create meaningful, coherent societies. Perhaps the most profound insight emerging from quantum time loop research is the recognition that time itself might be less like a river and more like an ecosystem, a living system that maintains its own health and balance through mechanisms we're only beginning to understand. In this ecological view of time, the mechanisms that prevent temporal paradoxes serve functions similar to the self-regulating processes that maintain ecological balance. Just as ecosystems develop feedback loops that prevent any single species from dominating completely, temporal ecology might employ quantum mechanisms that prevent any single causal chain from creating logical contradictions. The diversity of paradox prevention mechanisms, from superposition to entropy reversal to post-selection, mirrors the redundancy found in healthy ecosystems. Multiple species often perform similar ecological functions, ensuring that the system remains stable even when individual components change or disappear. This ecological perspective suggests that consciousness might play a role in temporal ecology similar to the role of keystone species in biological ecosystems. Aware beings might serve essential functions in maintaining the coherence and stability of local regions of spacetime through their participation in quantum measurement and observation processes. The health of temporal ecology might depend on the quality of consciousness that exists within it. Just as polluted environments affect the health of biological ecosystems, mental states characterized by confusion, contradiction, and incoherence might create disturbances in the local fabric of space-time. This remains deeply speculative, far beyond what current science can confirm. But the metaphor of temporal ecology offers a framework for thinking about consciousness as an active participant in cosmic processes, rather than a passive observer of predetermined events. As you move through your daily experience of time, consider the possibility that your consciousness might be contributing to the health of temporal ecology through the quality of awareness you bring to each moment. This doesn't suggest that thoughts directly influence physical events, but rather that consciousness might participate in maintaining the consistency and coherence of local reality. When we examine quantum temporal loops from the broadest possible perspective, we discover patterns that repeat across every scale of existence, from the smallest quantum interactions to the largest cosmic structures. These fractal patterns of consistency suggest that the same fundamental principles operate throughout the universe, creating coherence through recursive processes that loop back on themselves at every level. At the quantum scale, particles maintain consistency through superposition and entanglement. At the biological scale, organisms maintain coherence through homeostasis and adaptation. At the psychological scale, consciousness maintains continuity through memory and identity formation. At the social scale, communities maintain stability through culture and institutions. Each level displays the same essential pattern: systems that maintain coherence while allowing for change, structures that preserve identity while enabling growth, processes that prevent contradiction while fostering creativity. The mechanisms differ at each scale, but the underlying logic remains constant. This universal pattern suggests that the contemplation of quantum time loops illuminates something fundamental about the architecture of existence itself. We live within a cosmos organized according to principles of consistency that manifest in countless forms but serve the same essential purpose, maintaining the logical coherence that makes existence possible. The fractal nature of these patterns means that understanding gained at any scale can illuminate processes at every other scale. The insights emerging from quantum temporal research might apply to personal psychology, interpersonal relationships, ecological systems, and cosmic evolution. This doesn't mean that all these phenomena operate according to identical mechanisms, but rather that they reflect variations on universal themes of consistency, coherence, and paradox resolution. The same creativity that prevents quantum paradoxes might inspire artistic innovation. The same patience that allows entropy reversal might support psychological healing. As you contemplate your place within these nested patterns of consistency, notice how your individual existence participates in processes that extend from quantum to cosmic scales. You are simultaneously a quantum system maintaining coherence through countless molecular interactions, and a conscious being participating in cultural patterns that span generations. As our exploration of quantum temporal loops approaches its natural completion, we find ourselves returning to where we began, but with understanding deepened by the journey through mathematical landscapes and philosophical territories we could barely have imagined when we started. We began with the paradox of time looping back on itself, and discovered that the universe possesses elegant mechanisms for maintaining consistency even in the face of logical contradictions. We explored how consciousness might navigate temporal loops and found connections between quantum mechanics and the deepest mysteries of awareness and identity. The journey has revealed that reality operates according to principles more subtle and beautiful than everyday experience suggests. The cosmos doesn't just tolerate coherence, it actively creates and maintains it through processes that span scales from quantum to cosmic. We exist within a universe that values consistency enough to employ the strangest features of quantum mechanics rather than permit logical contradictions. This return to our starting point with deeper understanding mirrors the structure of temporal loops themselves. Like systems traveling through closed time-like curves, consciousness can journey through complex territories of thought and return to familiar questions with new appreciation for their depth and mystery. The circular nature of this exploration reflects something fundamental about how understanding develops. Knowledge doesn't just accumulate in straight lines, but evolves through recursive processes that revisit familiar themes from new perspectives, creating layers of meaning that deepen with each return. Perhaps this is the deepest teaching offered by quantum temporal loops, that reality itself might be organized according to principles of return and deepening, cycles within cycles that create meaning through their recursive structure rather than their linear progression. As you prepare to return to the ordinary flow of time from this exploration of its most exotic possibilities, carry with you the awareness that every moment participates in patterns of consistency that extend from quantum mechanics to cosmic evolution. The same principles that would govern consciousness in temporal loops operate continuously in ordinary space-time, creating the stable foundation that allows existence to unfold in coherent patterns. In these final moments of our journey together, let yourself settle into the quiet recognition that you've touched something profound about the nature of existence itself. The quantum mechanisms that make time loop back on itself reveal not just exotic physics, but fundamental truths about how reality maintains its coherence and beauty. The universe we've explored together is simultaneously more mysterious and more trustworthy than everyday experience suggests. It's a cosmos that employs quantum superposition rather than tolerate logical contradictions, that reverses entropy rather than permit temporal paradoxes, that maintains consistency through mechanisms so elegant they approach the miraculous. You exist within this remarkable reality, not as a separate observer, but as an integral part of the processes that create and maintain cosmic coherence. Your consciousness participates in the ongoing dance of consistency that operates from quantum scales to cosmic dimensions, contributing through every moment of awareness to the universe's commitment to logical harmony. The contemplation of temporal loops reminds us that even the most exotic theoretical possibilities reveal something essential about the nature of ordinary existence. We live within a reality that protects its own consistency through quantum mechanisms operating continuously throughout space-time, ensuring that the flow of time maintains its fundamental integrity. Take a gentle breath and notice how this understanding might shift your relationship with the passage of time. Each moment carries forward something precious from what came before, while opening space for new possibilities to emerge. You move through time not as a passenger carried by an external current, but as a participant in cosmic processes that create meaning through their own internal consistency. The principles we've explored together, from quantum superposition to entropy reversal, operate as gentle guardians of causality, ensuring that the universe maintains its logical coherence while allowing for creativity, growth, and transformation. These mechanisms don't force consistency through violence or constraint, but create it through elegance and patience. In the quantum realm where time can loop back on itself, paradoxes resolve themselves not through struggle, but through the natural operation of consistency mechanisms that honour all possibilities while maintaining essential harmony. This gentle approach to paradox resolution offers wisdom that extends far beyond theoretical physics into the practical art of living with grace and trust. As you drift forward through the ordinary flow of time from this moment, remember that you carry within your consciousness traces of the journey we've shared. While memories of specific details may fade, something deeper remains, an appreciation for the profound mystery and elegant consistency that underlies all existence. The universe that makes time loop back on itself is the same universe that carries you from past to future through the gentle certainty of quantum mechanical processes operating at every scale of reality. You exist within a cosmos that knows how to maintain its own deepest truths while remaining forever open to new possibilities. Rest in the knowledge that the same principles governing exotic temporal loops operate continuously in ordinary space-time, creating the stable foundation that allows consciousness to flourish and meaning to emerge from the dance of possibility and actuality that unfolds in every moment. Next time, we'll explore how these same quantum principles of consistency and coherence might shape not just time itself, but the very nature of perception and reality in The Science of Reality and Illusion. Why no two minds see the same world. Until then, drift peacefully in the awareness that you are part of something extraordinary, a universe committed to its own consistency through mechanisms so subtle and beautiful they transform even the strangest theoretical possibilities into expressions of cosmic wisdom. Cosmic, sweet dreams, fellow traveller through the looping paths of time and consciousness. May your journey through ordinary moments be touched by the wonder of knowing that you exist within a reality far more elegant and mysterious than imagination alone could conjure. As our journey through temporal loops reaches its deepest point, we encounter something that challenges our most fundamental assumptions about memory, information, and the nature of experience itself. The quantum mechanisms that prevent temporal paradoxes operate through processes so subtle that they leave traces in consciousness while erasing all surface awareness of their operation. Dr. Gavasino's equations reveal that when a system completes a journey through a closed timelike curve, it returns to its starting point, carrying information patterns that exist below the threshold of conscious detection. These patterns aren't memories in any conventional sense. They're quantum impressions encoded in the fundamental structure of matter and energy that comprises conscious beings. Think of it like this. Imagine walking through a garden at night, unable to see the flowers or paths clearly, but somehow your clothing picks up traces of pollen and fragrance that persist long after you've returned home. You have no conscious memory of which flowers you encountered, yet your very being carries evidence of the journey in forms too subtle for ordinary awareness to detect. This quantum information persistence suggests something profound about the relationship between consciousness and physical reality. While the entropy reversal that occurs in temporal loops erases all accessible memories of the journey, the quantum substrate of awareness retains structural changes that reflect experiences that consciousness cannot remember having. Recent research in quantum biology, though still in its early stages, indicates that living systems might naturally operate according to quantum principles in ways we're only beginning to understand. Some studies suggest that certain biological processes, from photosynthesis to possibly even neural computation, employ quantum coherence to achieve efficiencies that classical physics cannot explain. If consciousness truly operates through quantum processes, as some speculative theories propose, then the information persistence we observe in temporal loops might reflect something fundamental about how awareness maintains continuity across time. Each moment of consciousness might involve quantum computations that preserve information patterns while allowing surface experiences to change and flow. Take a moment here to consider your own relationship with information and intuition. Have you ever found yourself knowing things you couldn't explain, having insights that seem to arrive from beyond the reach of conscious reasoning? While we cannot claim these experiences involve actual quantum information from temporal loops, they point to the mysterious ways knowledge moves through consciousness and reality. As we explore deeper into the quantum mechanics of temporal loops, we encounter one of the most haunting aspects of Bootstrap paradoxes: the existence of information that has no discernible origin point. This isn't just a theoretical curiosity, it represents a fundamental challenge to our understanding of how knowledge and meaning emerge in the universe. Throughout this gentle exploration, we've journeyed deep into realms where time bends back on itself, where paradoxes dissolve through quantum elegance, and where the universe reveals its profound commitment to consistency through mechanisms so subtle they seem almost alive. We've discovered that reality operates not through rigid rules, but through patient processes that honour all possibilities while maintaining the logical coherence that makes existence itself possible. The quantum mechanisms that prevent temporal contradictions, from superposition to entropy reversal to spontaneous discretization, remind us that we live within a cosmos far more mysterious and trustworthy than everyday experience suggests. These aren't just exotic physics phenomena. They're expressions of universal principles that create stability while allowing for transformation, that preserve meaning while fostering growth. Perhaps most remarkably, we've seen how these same principles that would govern consciousness in impossible time loops operate continuously throughout ordinary space-time, creating the foundation for the coherent flow of experience from moment to moment. You exist not as a separate observer of quantum mysteries, but as an integral participant in the ongoing dance of consistency that extends from the smallest particles to the largest cosmic structures. The universe that makes time loop back on itself is the same universe that carries you gently forward through each breath, each thought, each quiet moment of awareness, ensuring that the deepest truths remain stable, even as surface experiences continuously change and flow. Rest peacefully in knowing that you are held within something extraordinary, a reality committed to its own wisdom through mechanisms as elegant as they are mysterious.